There's a calculator for you, confirm some of the things we're doing. Okay, so the first thing to understand is that when we're talking about inverse trig, it's going to undo a trig function and it's going to make a missing angle. It is not the same as dividing. Is it the same as dividing? No. Please say inverse trig. Now, people say inverse sine, people say sine inverse. Either one of those is acceptable. In Oregon, I was taught to say arc sine. So I would say arc sine, arc cosine, arc tangent. Since I've been in Nevada now, I say cosine inverse, sine inverse, tangent inverse. So the order of those words isn't particularly important. The way it works is very similar to, like if you had 3x equals 12, you would get x equals 4 because division undoes multiplication. If you had the square root of x equals 11, and you want to know what x was, well, you would square both sides and you get x equals 121. Where we are here, and we have sine of x equals 0.35, we need to undo the sine function on x. So we're going to take the sine inverse of this side, and we're also going to take the sine inverse of this side. And when we take the sine inverse of sine, the sine inverse of the sine of x, we just get x, just like we do when we square the square root, when we divide by the opposite of multiplication. So x is going to be whatever the sine inverse of 0.35 is. Let's go ahead and calculate that. Do you have that number for me? To the nearest tenth, please.
20.5 to the nearest 10. No?
20.5, yeah. I got 20.49, which is correct. So 20.5 to the nearest 10. Now I'm big on using the approximation mark instead of the equal sign. 20.5. Okay, we're going to do that x equals the tan inverse of 1.72. It's acceptable not to write the algebra at some certain point. What did you get for that one, please?
59.8.
59.8?
Yeah, rounded.
Rounded, good job. All right, cosine of x equals 3. How do we get x by itself? Take the cosine inverse. So we're going to have the cosine inverse of 3. Means x is equal to cosine inverse of 3. What answer did they give you?
A domain error.
Domain error. Why can't you figure it out? Get it right. Let's see what this is really saying. This is saying we have a right triangle where the adjacent side is 3. It's kind of like a 3 over 1. The adjacent side is 3 while the hypotenuse is 1. So the domain error isn't because you made an error. It's not because the calculator makes an error. The domain error is because cosine cannot be bigger than 1. You can't have an adjacent side that's bigger than the hypotenuse. So this one, what'd you say, domain error?
Yeah.
I'll put NA, and if I want to overrule that in the future, I reserve that right. But it's not applicable. Okay, let's do some more that are applicable. Let's do them just a little bit faster. Go ahead. Tan inverse of 25, please.
87.7.
87.7. Sine inverse of 0.5.
30.
30.
Yep.
30? We like that number. So it's exactly 30. We will not put that it's approximately. We'll say it's exactly 30. You did the sine inverse of 0.5. We'll talk about that one in just 1 second. And then we got the cosine inverse of 0.882.
28.1.
Cosine inverse of 0.882. I'm sorry, one more time?
28.1.
28.1, thank you. Okay, so let's do the same kind of drawing for this sine of 0.5. So let's go ahead and take the perspective of the top angle. It doesn't really matter. It's saying that it's 0.5. How do you think of 0.5? I think of 1/2. So it's really like the sine of 1/2. It means the opposite of the angle is 1, and the hypotenuse of that triangle is 2. And we know this triangle. This is the 30, 60, 90 triangle. This is the 1, 2, root 3 triangle. And so it does make sense that the sine of 1/2 would give us exactly 30. This is an exact answer of 30. It's not these rounded answers we've done. I'm going to give you number 9 for free. Go ahead and copy that down. Go ahead and copy it down now. So we took the perspective of x. The adjacent side was 5, the hypotenuse was 11. So we did the cosine inverse of 5 over 11. I would really kind of like to see your work a little bit more on the lines of cosine of x equals 5 over 11, and then go into this step. If you just give me this answer and it's correct, good job. If you give me this answer and it's a little bit wrong, and I don't see anything that looks like this or like this, and I don't know what you're thinking, I can't give you any points. Head number 9 for free. 62.96 to the sound says around to the nearest hundredth. All right, we got quite the beast here. We got quite the beast. Example 10. You're trying to solve the right triangle. That means we have to get everything. So we're given 2 sides and an angle. We're given an SAS scenario. We need to find out 1 question mark, 2 question mark, 3 question mark. We've got 2 angles to find, and we've got 1 side to find. If I have a side of 3 and a side of 4 in a right triangle, 3, 4, 5. Okay, so we got AC. It's a good idea to just write down everything. So I just figured out AC. I might as well write down that AB was 4 and that BC was 3. Okay, now I've got to tell me what all of my angles are. Did I make a mistake?
Yeah, other way around.
Other way around, thanks. 3 and 4. Okay. Now, which of the angles do I know? Go ahead and tell me.
B.
B. Angle B is
90.
90. That's the right angle. Okay. So obviously my task is to go find angle A and angle C. We've got, so this is the Pythagorean triple. Okay, so angle A. And take A's perspective. I could pick any of the numbers, but I'll limit myself to the 3 and the 4 because they were given in the problem. I'll make less mistakes that way. The 4 corresponds to the opposite of angle A. The 3 corresponds to the adjacent. And so we're going to get that the tangent of angle A is equal to 4 over 3. Now when we had cosine of 3 over 1, it gave us error. If we had that same thing with sine, it would give us an error. Each of those numbers need to be below 1. Tangent, is it okay for one side to be bigger than the other side? Sure. So this should not give us an error when we get that A equals the tangent inverse of 4 over 3. You go ahead and calculate. I'll go ahead and calculate. Tan inverse, 4 divided by 3. Answer please to the nearest 10.
53.1.
53.1. 53.13 rounding to 53.1. Okay. Would it be reasonable to now go ahead and erase our eyeball and put it on C and then make a new equation and then use another inverse trig function to find angle C? Would that be reasonable?
Mm-hmm.
Sure. Is it the best way to go?
Nope.
Not quite. You now have a triangle that is 90 by 53.1. You're trying to find that. Add, and use the triangle sum theorem to get the missing side. I'm sorry, the missing angle. So this is going to be 90 plus 53.1, which is 143.1. We're going to subtract that from 180 to get 36.9. So angle C equals 36.9, and it doesn't quite equal it, it's approximately equal to it. Pro tip, pro tip, pro tip, pro tip. Fair pro tip, just add 53.1 plus 90, subtract 180. Your calculator will give you a negative answer. Ignore the negative and write down the answer. Pro tip. Let's be done, let's be done, let's be done. Oh, I'm trying. I'm gonna let you have this one for free as well. Go ahead and get this copy down. If we have extra time left in class, feel free to help each other out, get started on the homework. Expect a quiz when I see you on Monday or Tuesday. I took the perspective of angle A, and I figured everything else out. That's it. Alright. Well, I'll add just a little bit more onto this video in just a second. I'm going to just go over the 3 ways the algebra can go. It's really not that complicated. You're going to be fine with it. It's definitely one of those topics that make sure you can set up the equation, put the eyeball somewhere, label OA and H, pick your trig function, and go from there. Alright, see you in a second. Go ahead and kill the recording.